Hi viewers, it is very good morning. So morning to video it is. So before watching this video, please subscribe, like it, and share it to your friends. And channel name is s.s space physics. Don't forget this video watching till the end. And it's the most important thing is thermodynamic potentials. Okay. So what is the potentials here? Thermodynamic potential. Thermodynamic potential definition. See, the thermodynamic functions or potentials are the energy functions formed by combining basic thermodynamic variable such as pressure, volume, temperature, and entropy is called as thermodynamic potential. Okay, so like this, the thermodynamic potentials we define once again. Thermodynamic functions, so we also called as thermodynamic functions or thermodynamic potentials are the energy functions, so all are the energy terms only. Okay, so whatever we discuss, those are we are going to discuss, those are all energy functions, and those functions present in terms of pv and pvt, and yes, that is easy. Okay, how we get this energy function? By combining basic thermodynamic variables such as, so these are the basic thermodynamic variables. So by combining these thermodynamic variables, we get thermodynamic potentials or thermodynamic functions. There are four different types of thermodynamic potentials we have. What are those? See, internal energy. In the internal energy of the system is the energy which it possesses due to its molecular constitution and motion. So here, this internal energy how we get? So it is because of its molecular constitution and motion. Molecular motion gives kinetic energy, molecular constitution gives potential energy, and those combination is internal energy of the molecules. This is the sum of kinetic energy. See, kinetic energy due to motion, and a potential energy due to mutual attraction, whether attraction and repulsions also, but in substance attractions present mostly. Next, according to first law of thermodynamics, when a system passes from one state to another state, change in internal energy doesn't depends upon the path followed, but depends only on initial and final state. Okay, so that is why initial and final state, when it depends upon initial and final state, so this is also called as state functions. Okay, state functions also we call state function means anything which depends upon the initial and final path, and which cannot depends on the path followed, only depends initial and final, so that is why it is state function. Okay, yeah, from initial to final. Next, the change in internal energy is given by, so change in internal energy how can we get? By using the first law of thermodynamics. It is first law of thermodynamics, and from this we write dq. From this, dq is equals to uh, du is equals to dq. If you bring this is this side, okay, it becomes du is equals to dq minus dw, and dw is also called as pdv. Okay, so don't forget this is a relation pdv. So dq is equals to du plus minus pdv. And from second law of thermodynamics, what? Second law of thermodynamics, dq is equals to tds. Am I right? So that is why second law of thermodynamics, dq is equals to tds is written. Okay, so this is a change in internal energy, or it is a connection between first law and second law of thermodynamics. Okay, it is not only change in internal energy, and also indicates to us what? It is a relation between first and second law of thermodynamics. Okay friends, now second one is enthalpy or total heat function. Enthalpy or total heat function. What is enthalpy? Enthalpy is an extensive thermodynamically property and mathematically expressed as, so it is a thermodynamic property. Enthalpy, or its another name is total heat function. It is denoted by h. H is equals to u plus pv. It is enthalpy formula. H gives a heat content at constant pressure. So it always gives heat content at constant pressures. Just as internal energy U gives heat content at constant volume. So it is a constant volume and it is at constant pressure. Change in enthalpy can be obtained by differentiating above equation. So this is a differentiation we have to calculate. So whole aim is what? If you want to explain internal energy or enthalpy, you should write finally their changes only. So internal energy change is written. Now enthalpy change we have to write enthalpy change. For this what I am doing, see, differentiation. Dh, both side dh d we have to applied. Yeah, okay, right, it is in multiply inside du, it is a du of pv. So right, it is uv method, pdv plus vdp and du. So du value is what again? So from the above equation, so this is du is equals to tds minus pdv. Okay, so this is taken here again. Okay, and substitute in the place of this du. So tds minus pdv, pdv gets cancelled. What is final? TDS plus PD, VDP. TDS plus VDP. It is change in enthalpy. Okay, friends. Next, Helmholtz function or Helmholtz free energy. So Helmholtz free energy is denoted by F. From first and second law of thermodynamic, it is just now I told you. It is a first and second law relation. It is du is equals to TDS minus PdV. And now consider a process in which system changes heat with the surroundings and hereby maintains the temperature constant. Okay, suppose any functions, any system is maintaining constant temperature, then we write TDS as d of Ts. Okay, TDS as d of Ts. So that means it is written this side. Okay, like this. And in the place of TDS, see here above, see here above, in this place what we have to write, this is we have to write, yes, written, and bring this is this side, it becomes minus. Am I right? And take d common outside, so we write it is like this, u minus ts is equals to minus pdv. So u minus ts is let me replace these three quantities with a single term, that is called f only. So df is equals to minus pdv. Pdv also written as dw minus dw. So where in the which place it is replaced by f only. So f is equals to tu minus ts. It is a free energy formula or Helmholtz free energy or Helmholtz function formula. Now it's a change we have to write finally. Finally, their change, whatever thing you take, their change we have to write. So that means differentiate it. This is known as Helmholtz free energy or work function. Change in Helmholtz free energy can be obtained by differentiating above equation. So differentiate it. So like this, df is equals to d of this one. Multiply d value inside. We get like this. And a du value we know it is du, right? Now it is UV method. TDS minus VS dt. Why? Because minus is there. Its UV method is TDS S dt. Okay. So minus is multiplied inside. So that becomes like this. And in the place of du, TDS minus PdV. So that is already we know the formula. TDS minus PdV. Now TDS and TDS gets cancelled. So finally what we got? Minus PdV and minus SDT we got. So df is equals to minus PdV minus SDT. It is change in Helmholtz function. And last one is Gibbs function. It is a Gibbs one. From the change in enthalpy. So change in enthalpy equation is there. What is that? See here once again. dH is equals to TDS plus VDP, change in enthalpy. So for this I have taken TDS plus VDP. Okay, it is. Now similarly, how it is again we have to change like this. Above we change TDS present when in isothermal process, TDS can be written as d of Ts. Okay, now replace this with the t of Ts. And enthalpy, so just now I explained that I explained you enthalpy is at constant pressure. See here, heat content gives it constant pressure only. So that is why when pressure is constant, its a differentiation is what? Zero. So its a differentiation is zero. So this place is zero. Only TDS, and it is TDS is written as d of Ts, like this. Now bring this is this side. What is it? Becomes minus, and take out common d, h minus Ts. So it d of this is zero means it must be constant. according to differentiation. Am I right? So suppose a constant is there, and if you differentiate it, what you get 0 when you get 0 when it is constant. So that is why it is taken written as constant, and this constant is denoting with the g. Okay, so this g is called Gibbs function. This constant is called Gibbs function and denoted by g. Thus g is equals to h minus ts. Okay, so it is a Gibbs function formula, but we need change in Gibbs. For this, what we have to do, we have to simply differentiate on either side. This function g remains constant if thermodynamic process remains isothermal as well as isobaric. Isobars means pressure constant. Change in Gibbs function can be obtained by differentiating our equation. So this equation definition. So dg is equals to d of this one and multiply d inside. It is like this and keep it like this, and it is UV method, TdS minus SDT and dH. So already we calculated dH above, TdS plus VdP. See here where it is, TdS plus VdP. So that formula is substituted here, TdS plus VdP in the place of this, and which one cancel, this one and this one gets cancelled. So finally we got this one. Okay, so like this friends. So you must remember what things you have to remember here. First of all, you should remember first their headings, internal energy and its change value. So like this one, internal energy and their change value. And next, what is second one is enthalpy or total heat function and its change value. Its change. Okay, not only change, and also you have to remember this one. Next, third one is what? Third one is Helmholtz function or Helmholtz free energy. So Helmholtz function or free energy is a what? So it is not only this one you have to remember, and also its change. Its change. This is these two things. It is most important than this one. And next, last one is Gibbs function. So Gibbs function formula not only this one and also its change. So why? Because by using this change only, Maxwell relations we can calculate. If you want to know, if you want to easily remember the Maxwell relation, then you must remember all these differences. Okay friends, so don't forget this video watching till end, and you must remember internal energy, enthalpy or total heat function. Second one it is. Third one is Helmholtz function or Helmholtz Helmholtz free energy, and fourth one is Gibbs function. So don't forget these four things. These four things are called thermodynamic potentials. Okay, thermodynamic potentials are four things only. Okay friends, thank you.